Another way that we can use molarities is as part of a limiting reactant problem. So we've talked about limiting reactant problems earlier, and when we did that, one of the things that you need to give as part of the problem is information to get the number of moles of reactants. So previously what we did was give you grams of reactants, and with that you would divide by the molecular weight and come up with the number of moles of reactants. Another way that we can give you information about moles of reactants is by giving you volume and concentration. In reality, this is a more common way of looking at limiting reactant problems, that usually our reactants are dissolved inside of solvents. So this is very important. So here we're mixing two solutions of soluble salts, and we're saying that a precipitate forms, and we want to know what the theoretical yield of that precipitate. So the basic steps are kind of the same, finding the theoretical yield as part of a limiting reactant problem. The first thing I want to do is find out what reaction's going on, balance it, and then determine the precipitate. So here we want to take our soluble salts and figure out what ions they form when they're dissociated, and we want to recombine those ions to make our products. So we're mixing sodium sulfate and silver nitrate together. Sodium sulfate, when it dissociates, makes Na plus and SO42 minus, and silver nitrate makes Ag plus and NO3 minus. So we take the positive from one and the negative from the other, and recombine them to get our products. So sodium and nitrate comes together, Na plus and NO3 minus. It's a 1-to-1 ratio of the charge. So sodium nitrate is going to be one of our products. Here we're taking Ag plus and SO42 minus. So we're going to need two Ags to make a +2 charge to counteract the -2 charge of sulfate. So our product here is going to be silver sulfate. When we look at this, we understand that one of these two products is going to be an insoluble salt. We know that because we're told that a precipitate forms, and we know that sodium nitrate is a soluble salt because any salt that involves sodium, a group 1 metal, is soluble, and then also any salt that involves nitrate is soluble. So our product, our precipitate, has to be silver sulfate. So we go ahead, we're given the reactants, we found what the products are, and you go ahead and balance them to come up with the overall balanced reaction. The next step is to determine which one of our two reactants is the limiting reactant. And as always, there's a few different ways of calculating this. What I like to do is to look at how many moles of product each reactant would make if they were all used up, and then compare those numbers together. So if all the sodium sulfate is used up, I want to determine how many moles of sodium sulfate I have. So remember, moles is equal to molarity times volume. So I have 0.8 molar sodium sulfate, and I have 15 milliliters of it, or 0.015 liters. So these two numbers multiplied together gives me the number of moles of sodium sulfate that I'm putting into the reaction. I then need to use the mole ratio to figure out how many moles of product would be made if I used up all my sodium sulfate. I go to my reaction and I see that it is a 1-to-1 mole ratio. It says for every 1 mole of sodium sulfate I use up, I make 1 mole of silver sulfate. So here, when I do this calculation, if I use up all of my sodium sulfate, I will make 0.012 mole of silver sulfate. So this is part of the equation. So I've looked at how much of my product I would make if I used up one reactant. Now I've got to look at the other reactant, silver nitrate. Silver nitrate was 0.6 molar, and we had 25 milliliters of that. And remember, we convert milliliters to liters. Here, the big difference is that it is a 2-to-1 mole ratio. So my reaction tells me that for every 2 silver nitrates that I use up, I can make 1 silver sulfate. So it's a 2-to-1 mole ratio. Remember, these two numbers together, molarity times volume, gives me the number of moles of silver nitrate. We use the mole ratio to do a conversion, and this number tells me if I use up all of the silver nitrate, how many moles of my product, silver sulfate, will be made. Once I have these two numbers, I then do a comparison and say which one produces the smallest amount of moles of my product. And in that case, it is the 0.0075 mole of silver sulfate. Whichever reactant produced that, in this case the silver nitrate, that is my limiting reactant. How many moles it produces is the number of moles of product that is made. So once I have the number of moles, the next step is to actually find the theoretical yield. So remember, when we say theoretical yield, we're talking about grams. We don't want moles. So I have to convert my number of moles of silver sulfate into grams of silver sulfate. So remember, the calculation is moles times molecular weight gives me grams, or in this case theoretical yield. So if I take the number of moles of product, which I just found here, times the molecular weight of the product, which I can find from the molecular formula Ag2SO4, that'll give me my theoretical yield for this reaction. So we just calculated that we can make 0.0075 moles of silver sulfate. The molecular weight of silver sulfate is 311.8 grams per mole. When we multiply these two things together, we get the theoretical yield for this reaction, which is 2.3 grams of silver sulfate.